Hello everyone. Welcome to the Classroom of Advanced Manufacturing Technologies for Welded Structures. I am Huang Bin, and today we will learn about the operation of plate rolling machines. I hope that through this lesson, everyone will master the basic operation methods and techniques of the plate rolling machine. Today's content is divided into 3 parts. Number 1. Basic structural principles of the equipment. Number 2. Plate rolling machine operation. Number 3. Equipment maintenance and troubleshooting. We will explore each section in detail to ensure you gain a comprehensive understanding of plate rolling machine operation. Let's begin with the basic structural parameters of the plate rolling machine. The workshop is equipped with 4 3-roll plate rolling machines. Currently in use are the number 40, number 60, and number 80 models. The number 40 and number 60 machines are symmetric types, while the number 80 machine is a universal type. These rolling machines are primarily used for forming circular and arcuate workpieces. Next, let us examine the key technical parameters in detail. The upper roll pressure, plate material, upper roll diameter, lower roll diameter, center distance between the 2 lower rolls, bending speed, and the maximum and minimum rolling diameters all vary among the number 40, number 60, and number 80 plate rolling machines. These parameters directly influence the machine's performance and its range of applications. The primary structural components of a plate rolling machine include the upper roll assembly, lower roll assembly, support roller assembly, tilting assembly, main drive unit, balancing device, and cone attachment. Each component serves a specific function, and together they accomplish the plate rolling operation. The upper roll assembly is composed mainly of the upper roll itself, the main hydraulic cylinder, the upper roll bearing housing, and double-row, double-column self-aligning roller bearings. Hydraulic cylinder action raises and lowers the upper roll, providing the main rolling pressure for the plate. The lower roll assembly consists of the lower roll bearing housings, the lower rolls themselves, and the lower roll input gears. This assembly supplies both forward and reverse torque to the plate during rolling. The horizontal moving device, unique to the number 80 rolling machine, enables pre-bending of the plate ends to facilitate asymmetric rolling. The support roller assembly is composed of support rollers, their bearing housings, the connecting frame, and wedge blocks. When rolling thick plates, the support rollers rise to prevent the lower rolls from bending and avoid bagging of the workpiece. When rolling thin plates, the support rollers descend so that the curvature matching the upper roll barrel is generated on the lower roll, preventing a waste deformation. The tilting device comprises the tilting hydraulic cylinder, sliding cradle, and base. The tilting cylinder is a single-stage hydraulic cylinder, connected to the frame via a hinge pin, which pivots the tilting frame to allow removal of the finished product. The main drive unit includes an electric motor, planetary gearbox, support brackets, hydraulic motor, and output gears. The number 60 and number 80 machines use a dual drive arrangement, whereas the number 40 machine employs a single drive system. The balancing device, made up of 2 tie rods and a balance beam, maintains equilibrium of the upper roll. The cone attachment is a special accessory consisting of a support base, cover plate, bushing, hinge shaft, pin, baffle, and locating pin. In use, the hinge shaft is fixed at a 60 degrees angle to the horizontal. To roll a conical shell. 1. For rolling a conical shell, cut the blank to the required dimensions and secure the cone attachment's hinge shaft at a 60 degrees angle to the horizontal. 2. Position the plate against the cone attachment's roller sleeve and adjust the upper roll's angle. 3. During rolling, the workpiece presses against the bushing, creating frictional resistance. At the same time, the bushing restrains the workpiece's longitudinal movement, inducing controlled slip during feed and thus progressively forming the part. 4. Upon completion, tack weld the seam to close the cone and remove the finished product. The roll changing device includes a smaller upper roll, eccentric sleeves, and bushings for rolling small diameter shells. Its applied pressure must not exceed 60% of the main upper roll pressure. Key steps for changing rolls. The roll changing procedure includes removing the large upper roll, installing the small upper roll, adjusting its position, and performing test runs. During the roll change, special attention must be paid to leveling the upper roll and correctly setting the rolling pressure. 1. Raise the large upper roll and tilt the side frame. 2. Use an overhead crane to lift and secure the roll. Then remove the fixed side bearing cap. 3. Loosen the balance beam of the balancing device. 4. Remove the large upper roll. 5. Install eccentric sleeves in both the tilting side and fixed side bearing housings. 6. Mount the small upper roll into the fixed side bearing housing. 7. Use wooden blocks or the crane to position the small roll so that the tilting side frame can close. 8. When the tilting side frame can close, operate the roll cylinder to raise and lower the roll. 9. Once in position, adjust the balance beam to press against the roll tail, ensuring a level alignment throughout movement. Adjust the electromagnetic relief valve so that the main system pressure gauge reads a maximum of 11 to 12 megapascal. You may repeat this adjustment 2 to 3 times. Once set, tighten the locking nut on the relief valve. Note: continuously monitor and correct the upper roll's level throughout its movement. After completing the roll change, reverse the sequence to swap back between the large and small upper rolls. When switching from the small roll to the large roll, raise the balance device before lifting the large roll to avoid bending its tail. Next, we will explore the equipment operation. Before starting, check the oil level in the main drive reservoir, all machine lubrication points, and the hydraulic tank level. Preparation steps include connecting the power supply, ensuring the tilting side frame is fully reset, verifying motor temperature, and so on. All functions are controlled via the portable button box and the operator console. The lifting and lowering of the upper roll are controlled by the operation buttons. 1. To raise the upper roll, press the up button. The upper roll will begin to rise. Release the button to stop the roll at any desired position. 2. To lower the upper roll, press the down button. The upper roll will begin to descend. Release the button to stop the roll at any desired position. 3. The fixed side and tilting side frames can be lowered independently. Lower roll drive and tilting. The lower rolls can rotate forward or reverse. The tilting frame flips or resets automatically under hydraulic cylinder action. The symmetric rolling process includes the following steps: blanking, end pre-bending, plate placement, multipass rolling, roundness inspection, tack welding, and final roundness correction. 1. Perform blanking according to the part specifications of the rolled product. 2. Pre-bend both ends of the plate on the press to the required radius using end-forming heads. 3. After pre-bending, suspend the plate onto the lower rolls and align it. 4. Perform multi-pass rolling. Lower the upper roll by a certain distance and drive the lower rolls to begin rolling. Then lower the upper roll further and continue rolling. Repeat this process multiple times until the ends of the steel plate meet. 5. Check whether the rolled arc meets the product requirements. If not, correct the roundness. 6. Once rolling is complete, tack weld the seam to finish the circular shape. 7. At the end of the process, raise the upper roll to its stop position, tilt the frame, and remove the workpiece. 8. Reiterate symmetric rolling procedure as needed. 9. Weld the seam fully and grind smooth. 10. Raise the upper roll, tilt the frame, and feed out the cylindrical workpiece. 11. Lower the upper roll, drive the lower rolls, and perform final roundness correction until specifications are met. 12. Repeat the above steps for the next workpiece. The asymmetric rolling process includes centering the incoming plate against a backstop, lowering and laterally shifting the upper roll, forming the plate, end pre-bending, and compensation bending. During asymmetric rolling, operators must pay close attention to the plate's feet position and direction to ensure accurate end pre-bending. Operators should adjust the upper roll position and the lower roll rotation direction based on the plate's forming progress to maintain rolling quality. Throughout the process, operators must continuously monitor the plate's movement to ensure both safety and product quality. Operating regulations. 1. Operators must understand the machine's structure and performance and hold valid certification. 2. Inspect all components and drive systems before powering up. 3. Monitor for any abnormalities during operation and stop immediately if detected. 4. During rolling, operators must stand at the sides of the plate, never at the ends. 5. Use templates to check roundness only after the machine has come to a complete stop. Now let's learn about maintenance and troubleshooting. Daily checks. Inspect the hydraulic power unit's exterior oil level and piping for leaks. Scheduled inspections. Conduct detailed examinations and verify hydraulic system operations. Replace the hydraulic oil annually to ensure reliable system performance. Through today's lesson, we have covered the plate rolling machine's essential structure, operation methods, and maintenance points. I hope everyone can apply this knowledge in practical operations and continuously improve rolling quality and efficiency. Thank you. That concludes today's lesson. Through this lesson, we have explored in depth the operating methods and maintenance essentials of the plate rolling machine. I hope everyone will apply this knowledge in practical work and continuously enhance their operational skills. This lesson is concluded. Thank you all for listening and goodbye.